You know, every time you shop online or send a secure message or even just log into your email, you are relying on this invisible foundation of trust. It's a trust that's not based on a handshake, but on pure mathematics. So today, we're going to pull back the curtain on the one secret ingredient that makes our entire digital world work: randomness.
And this isn't just some techie problem, It's a huge societal goal. This quote here is from India's national cybersecurity policy, and it really gets to the heart of a global priority: creating adequate trust and confidence online. I mean, think about it. Without that trust, e-commerce, digital banking, all of it just wouldn't work.
So that's the big question, isn't it? How do you take something as human as trust and build it out of ones and zeros? What's the tool that lets two computers, total strangers on the internet, set up a secure, private connection that no one else can possibly listen in on? Well, the answer is surprisingly simple and, at the same time, deeply complex. The answer, of course, is cryptography. But at the very heart of cryptography lies something you might never expect: random numbers. That's right, the same idea you use to pick lottery numbers or roll dice in a game is the fundamental building block for all of our digital security. It is all about the power of unpredictability. And this randomness is used absolutely everywhere. It's used to generate those super complex keys that lock up your data, to create temporary keys for your secure connection to a website, and even to stop hackers from capturing old messages and trying to reuse them. It's really, truly the cornerstone of our digital security. But here's a really important distinction we have to make. When we talk about randomness for security, we're actually talking about two different things. First, there's statistical randomness, where the numbers are all evenly sped out, like rolling a fair die over and over. But for security, what's way, way more important is unpredictability. An attacker must have no way of guessing the next number, even if they know every single number that came before it. A sequence can look totally random, but if an attacker can predict it, it's completely useless for security. Okay, so this leads us right to the heart of the matter. How do computers, which are these fundamentally predictable, logical machines, produce something that's unpredictable? Well, it turns out they have two very different ways of doing it. One taps into the real-world chaos of the universe, and the other relies on a very clever mathematical recipe. First, let's talk about the purists: true random number generators, or TRNGs. A TRNG is an actual piece of hardware that measures some physical process from the universe, something that is fundamentally, truly impossible to predict. It's not creating randomness, it's literally capturing it. So what kind of physical process are we talking about here? Well, it could be measuring the teeny tiny fluctuations of heat in a computer chip, or the decay of a radioactive particle, or even just atmospheric noise. Static. These are genuinely chaotic natural events. The data isn't calculated, it's harvested from the world around us. This is as random gets. But then we have the workhorses of the internet: pseudo-random number generators, or PRNGs. And just like the name says, this is pseudo, or, fake randomness. A PRNG isn't hardware, it's just an algorithm, a piece of software. It takes one starting number, called a seed, and it runs it through a bunch of complex calculations to produce a long stream of numbers that looks random. But really, it isn't. The best way to think about it is like a very, very complicated baking recipe. The seed, that's your unique set of ingredients. The algorithm is the recipe itself. Now, if you use the exact same ingredients and follow the exact same recipe, you will always get the exact same cake. It is completely deterministic. And that means if an attacker knows the recipe and your starting ingredients, they know every single random number you're ever going to make. Okay, that should sound absolutely terrifying, right? If our security is built on a predictable recipe, how can we possibly trust it? So why on earth are these fake random numbers the actual backbone of our digital world? Well, the answer reveals this really surprising kind of trust that's built on a very clever idea. The answer really comes down to just being practical. True random number generators can be slow, and they require special, sometimes expensive hardware. PRNGs, on the other hand, are just software. They are incredibly fast, super efficient, and they can run on pretty much any device. And for most things, a really well-designed PRNG is more than good enough. Its output is so complex that it passes all the statistical tests for randomness with flying colors. And this brings us right back to the most important point of all. This quote just nails it.
For security, we don't actually need true randomness from the universe. What we need is unpredictability from the perspective of an attacker. A good PRNG, even though it's totally deterministic, is designed to be so complicated that without knowing that secret seed value, trying to guess the next number is basically computationally impossible.
So we end up at this beautiful paradox. Our digital trust, the thing that holds everything together, isn't built on true chaotic randomness. Nope. It's built on predictable, deterministic algorithms that are just so exquisitely complex, their output becomes unpredictable to anyone who doesn't have that secret starting ingredient. We have literally engineered unpredictability.
It's a fascinating and maybe slightly fragile balance when you think about it. We've built our entire secure world on a foundation of mathematical illusion, a recipe that just pretends to be random. And it works. But it does leave you with one final thought to chew on. In a world where computers get more and more powerful every single day, how long will our clever recipes for unpredictability hold up? Is good enough really going to be good enough forever?